Enumeration of collections has been the bread and butter of many programs. But what if we could take this familiar concept and enhance it with asynchronous capabilities? That's exactly what .NET AsyncEnumerables do. In this video, we will explore how C# combines yield return with async and await to create asynchronous data streams, and how await foreach lets us effortlessly consume them. For the demo, I will show you a simple console application that looks through an Amazon S3 bucket which has product rating files in JSON formats. We will be looking through for specific conditions of product ratings to demonstrate the example of async enumerables. We will see some of the challenges with using normal approaches and then see how async enumerables helps us make this more efficient. This video is sponsored by AWS and is part of my C# series. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. Without much delay, let's learn more about async enumerables in .NET. Here in JetBrains Rider, I have a simple console application which has the program.cs. Here we have a new Amazon S3 client already created, which is using the .NET SDK for Amazon S3. Now, S3 is simply an online document storage from Amazon, which can be used to store documents. The concepts of async enumerables is not limited with S3. It can be applied to any kind of storage mechanisms or any kind of interactions that you interact across the network. Now, this could be calling an API, talking to a database, or even things like talking to cloud or file storages. So in our example, we have an existing bucket in Amazon S3 with the name user ratings for my app. So if I navigate into my Amazon console, you can see that bucket in here. And if we navigate into that, we can see a list of objects. Now these are simply product ratings in JSON format. So if I open one of these documents by navigating to it and let's say open. So this is going to open that. And you can see here, this is a simple JSON document which has a product ID, a rating, and also a review. Now we have a C# class to represent this object inside here, which is called product rating. Now this is simply a record type. Now if you're completely new to records, I highly recommend checking out the video linked here and also in the descriptions below. Now this currently gets all the ratings, which in turn calls a method. So if you navigate into the get all ratings, we will see that this is calling get all file S3 objects. So once navigating into that, it's using the Amazon S3 client and listing out the objects inside that bucket. For now, this is limiting to a max of 10 keys. And it returns all the object details. The object details in this case is nothing but details of each of these files. So it'll get the first 10 files in this case with our max keys of 10. Once we have the object details, we iterate through it and we download the document. So the get rating method is nothing but getting the actual object, converting it into the JSON object and returning it back. So once we have the list of ratings, we are returning that back to the main caller function. So this is going to apply a logic which says it just needs to look at all the ratings that has 3 and it takes the first 50 of them. Now since we are just reading 10, let's make this to be 2 for now. And it selects all the review properties out of that and just dumps it into the console. So let's run this to see this in action. So we can see in the console tab, we can see that this is reading the different files and then it's dumping the 2 product reviews for that product which has a rating of 3. Now in this case, I'm just looking for 2 because we were just reading maximum of 10 from our object file storage. Now let's say your application grows and we need to start reading through all your documents inside your S3 and get back more ratings from it. Now this is a typical example of paged data interaction. So we have a specific set of keys that we are getting in each request so we can keep paging the data. This is the constraint so that if the records grow in size, you can still fetch all the data from it as required. Now inside my bucket, I have around 5,000 objects which I had pre-created before. Now I don't want to be reading all 5,000 at once, and there might be also limitations in the API to read the maximum number of objects. Now by default, the max keys in S3 is around 1,000. So let's come back to our method and see how we can modify this to get all the S3 objects. Now in this case, we will have to implement the paged request. So let's do that first. So let me copy and paste this method replaced with the paging logic implemented, and I will walk you through it. So let me paste the new implementation where this creates an object response upfront and then it loops through this response data until it is not truncated. Now S3 object response sets is truncated to be true if there are more results to be returned. Now in this specific case, when the request is passed, we are specifying the bucket name. We are also specifying the continuation token if one exists from the S3 object's response. So we are checking for nullable and only then passing in the continuation token. Now start after says which object it read the last. So this next request will read the objects after that specified object case. So once these three properties are specified, we can do while in this particular loop and read to the end of the bucket. Now this specific method is building up the list of objects as it is reading it. So you can see we have defined a list of S3 object and adding each of these ranges into that. So once we have all the objects iterated and added into this result, we are returning it back from this method. Now in this specific case, this method is abstracting away the fact that this is reading from an external source and it is building all the work upfront. So let's run this and see this in action. So now if I come back and let's say instead of take 2, let's make this as take 50 so that we have more objects. Now let's also put a breakpoint inside line 21 once we have read all the S3 objects. Now as we read each of the page from the data, we are logging that total objects retrieved and logging that particular count. So let's run this to see this in action. Now it has hit the breakpoint, so let's switch over to the console tab, and here you can see that right now it's read all the 5,000 objects. So it has already read the 5,000 objects inside the bucket and right now going to loop through them to get each of the contents and convert them into the JSON. So we had to do all the upfront work to get the 5,000 objects. Now, as the number of objects grow, we will be returning that many items into our memory, and we'll also need to wait until all of these 5,000 objects are returned to start any meaningful work. So now you can see here, if I continue the execution, this is going to loop through and get all these objects from the Amazon S3. So let's open the console again. And you can see here right now it's going through the files and reading them one by one. So you can see this is going to be a time-consuming process. So let's stop this and see how we can make this more efficient. Now this is particularly because we are reading through all the 5,000 objects and building up a list again inside here before we actually apply the logic of filtering it down by the rating. So let's see how we can return a list upfront and see how we can introduce async for our benefit. So let's come down to our getAllFile S3 objects method, and instead of building up this list of objects, let's see if we can return the objects as we read them. So instead of task of IEnumerable of S3 object, let's return an IAsyncEnumerable. Now in that case, you don't need to return a task. Now for this specific method, I had chosen IEnumerable just to show that because it rhymes with IAsyncEnumerable. Now IEnumerable might not be the perfect choice to return type for such methods. Let me know in the comments below if you want to learn different return types and when to use what. For now, let's remove this and make this as IAsyncEnumerable. So let's remove the task as well and let's specify IAsyncEnumerable. Now this is going to return an IAsyncEnumerable type. Let's remove this extra bracket. And now this is showing an error. This is because it says the body of an async iterator must contain a yield statement. So let's remove this list of S3 objects as well because we don't intend to build up the list upfront. Now let's also remove the list.add. And now let's start yielding the results. Now since we no longer have the result, let's simply use the S3 objects response and let's use the S3 objects.count. So this is going to log how many objects have we read so far. So let's right after this line, let's foreach through this objects. So let's specify foreach and let's specify again the S3 object response and use the S3 objects because that is what we are going to return back as part of this method. Now in each of these objects, so let's specify this as S3 object, we can yield return that specific object. So let's return that. Now if you're not familiar with the statement yield, let me know in the comments and I can do a different video which explains that in detail. But for now, all we need to know is that this is going to return each of these objects back to this calling method. So let's now remove the return result because we no longer have this. So now you can see that this method is looping through the object response and returning each of them one by one. Now, once the next page comes, it's going to make a request to Amazon S3 and get back all the objects and return them again one by one. Now, let's run this and see what difference it has made. So let's run this again, and we've got an error. So if I scroll above to see the method, get all file S3 objects is now throwing an error. Because remember, we have removed the task keyword from this method, which means this is no longer awaitable. So let's remove that and let's see what we can do instead. So now since this is removed, we can say that the S3 objects is not possible to be enumerated like this. So this is where we can use the await for each, because we can iterate through each of these collections using that. So all we need to do is simply add a keyword await before the for each statement. This allows us to iterate through an async enumerable just like before with a for each statement. So now this is going to get back all the objects in an async enumerator and read them and return back the results. So let's run this and see this in action now. Now you can see that it has already hit the breakpoint. So if I switch over into the console tab, you can see there is still no records of hitting Amazon S3. So we haven't started enumerating through the collection, because of which it hasn't started asking S3 for the objects. So even if you have a lot of objects in Amazon S3, we haven't started reading it until we actually need those objects. So let's switch over this method. Once we start enumerating through this S3 objects collection, that is when it is going to hit the first request. So you can see here it has retrieved 1000 objects. This is because this is the paging size that we have chosen for now. Now you can adjust this based on the size of your objects and also the processing time that's going to take for each of these objects. Now once we have the 1000 objects, it's going to loop through this and get all the objects for that 1000. So now if I continue this execution, this is going to continue getting those files in order. Now we still have the problem of each of these files being read synchronously one after the other inside the for each loop. So this is going to go all the way till 1000 and then it's going to make the next request. So let's put a breakpoint in here to exactly see that. So the await for each statement is used to consume an asynchronous stream of data. Each iteration of the loop may be suspended while the next element is retrieved asynchronously. In our case, we upfront get 1000 objects in one request, so it is going to be suspended until the next 1000 is required. So now the breakpoint has hit again in our application. This is because it has run out of the 1000 elements to read and it is looking for more contents. Now you can see this is going to get the next set of 1000 objects and it's going to log that line which is saying it has retrieved again 1000 and it is going to loop through that. So now it's going to read from 1001 and it's going to continue that particular files. So once this next 1000 is going to hit, it is going to loop this again and again. Now again in this case, this is not that efficient because we are building up the list of products again inside our method here. So the get ratings is getting called one after the other inside a for each, which is getting back all the contents before we can start applying this logic. Now in this case, we only need a 50 and we don't care about the rest of them. So let's see how we can make this better. To start that, let's remove this for each and let's use LINQ to iterate this. So if I navigate in here, let's say S3 objects dot where, we cannot apply the normal LINQ methods on the IAsyncEnumerable. But that's where a NuGet package comes to the rescue. The system.link.async package was created to provide LINQ object implementations for the IAsyncEnumerable. So this makes it easier for interacting with IAsyncEnumerable types the same way we are used to interacting with normal enumerable types. So let's add this into our project. So let's go into our Explorer, let's manage and NuGet packages, and let's search for LINQ async package. So let's add the system.link.async to our project. So once we have installed this into our project, we can start using the normal methods on the enumerable on async as well. So let's search for where, and we can see that we have those methods back. So we can also use the select statement or any of the statements that we are familiar with using with enumerables. So in this case, let's convert this into a select statement. So let's say select await, and let's specify this as an S3 object in this case, and let's implement the function inside that. So let's specify this as an S3 object and write the function inside this. So let's open bracket and let's remove this for each, and let's move this function inside this. So for each of these things, we're going to do the exact procedure that the for each used to do. So let's close this as expected. Now, since we are awaiting inside this, let's also make this as a async method. So let's specify this as async so that we can await inside that function. Now, since we don't need to build up the list, let's remove this from here and let's simply return this object. So in this case, we can write this line and then return the rating object. So in this case, let's simply say return rating. So this is going to loop through this using a select await. Now, this again is not very ideal when you're dealing with large amount of objects which can be also large in size. Can you let me know in the comments what are some of the issues that can happen when you're using a select await on a collection like this? And if you want to learn more about it, let me know in the comments and I can do a separate video on that. But for now, let's simply use select await and keep moving forward. So now in this case, we can either make this return type to be again an async enumerable, or we can do the logic inside this itself. So let's move some of this logic inside here so that we don't have to change the type for this function. So instead of doing the calculations up here, we can do that inside this method. So let's remove these logics and simply say select r.review once this is coming back. So let's try and see how we can move that inside here. So once we have the select await, we need to apply the where clause on the rating object. So once we have a rating, we can specify rating.rating is equal to 3. Now, once we have that, we can also now take the 50 objects that we required. And once we need to materialize this list, we can call the toListAsync method. So that is going to create an enumerable from this particular collection. So let's call that and let's return this inside here. So let's simply say return and await this call because this is asynchronous. So now we have converted this into a select await and we're getting the 50 objects and returning the toListAsync. Let's see how this is going to work. So let's remove this where conditions from here and simply select the ratings inside this and log that as before. Now we also need to change this file read counter. Now this was already using an internal variable, so let's remove that, and instead of that we can use an index method. So let's specify S3 object and index, which is an overload of the select await, like the select method has this. So each of the items that's going to come here is also going to get an associated index. So we can simply log that inside this. So let's specify I, and that's going to log the count. So let's run this and see this in action. Now it's hit the breakpoint of get all file S3 object. So if I switch over to the console, you can see that no items has been retrieved yet. So once we step over this S3 objects and start getting each of these files, that is when it is first hitting the breakpoint to get the objects. Now once it has retrieved the first 1000, it is going to loop through those objects. So let's remove this breakpoint and continue the execution. So now you can see this is going to read through all the 1000 files again inside the select await. Now this case, you can see that it has hit the breakpoint of the filtered ratings once it has read till 200. This is because this has filtered enough number of elements, which is 50, as soon as it has read the first 200 objects. So if I continue the execution, it is going to log all those reviews and this program is going to end. Now if we have efficiently read the required documents to get the ratings that we need. Now if I change this to be the rating 5, and if we need only 20 of them, we can run this and it is going to read as many objects it's required to reach that criteria. So it's again going to hit that breakpoint. So let's continue the execution on this and look at our console tab. So you can see in this case, it is reading through the files and you can see it will stop in certain time, which is it has read till 175 objects to get 20 of 5-star ratings. So now, from reading all the object details from the objects and then iterating through each of them to get all the objects, we have cut down to just reading the first batch and just reading those many documents that we require to reach our criteria. So this has massively improved our application works and also the way we interact with this remote collections. I hope this helps you to look at some of the collections and the way you are interacting with them in your application and see if you can make them async enumerable. Thank you and see you soon in the next video.